Okay, so today I'm gonna start doing this data cleaning course. I'm gonna try to stream more often and then keep it to 1 or 2 hours stream so I can do my own projects outside of the stream. And then I can be more consistent on stream with streaming. I already clicked on join here, but I didn't do anything. That's why it's saying 10% there. It's taking me to the exercises right away. Welcome to the data cleaning course on Kaggle. Data cleaning is a key part of data science, but it can be deeply frustrating. Why are some of your text fields garbled? I don't know what's garbled means. I don't know what this word means in Portuguese. Okay, so it's incomplete. What should you do about those missing values? Why aren't your dates formatted correctly? How can you quickly clean up inconsistent data entry? In this course, you will learn why you've run into these problems and more importantly, how to fix them. Yeah, so this is just introduction. Take a first look at the data. The first thing we will need to do is load in the libraries and dataset we'll be using. For demonstration, we use a dataset of events that occur in American football games. In the following exercise, you will apply your new skills to a dataset of building permits issued in San Francisco. So this reads the data frame, and this I think creates a seed for the values. I think the first thing to do when you get a new data set is take a look at some of it. This lets you see that it all read incorrectly and gives you an idea of what's going on with the data. In this case, let's see if there are any missing values which will be represented with none or none. So there's a couple here. How how many missing data points do we have? Okay, now we know that we do have some missing values. Let's see how many we have in each column. It seems like a lot. You see the percentage dividing our data set we're missing to give us a better sense of the scale of this problem. So this gives the percentage. So I guess what this does is takes the product of the whole data frame, the amount of values there are in the data frame, because this shape here gives you the shape of the data frame, and p dot product is probably the multiplication. And those total missing values is the stuff that is said up there to get the amount. No, it's actually value counts. Missing value counts. Oh yeah, it's the sum. No, the missing value counts. It's dividing one by the other to get the percentage. Almost a quarter. Figure out why the data is missing. This is the point at which we get into the part of data science that I like to call data intuition, by which I mean really looking at your data and trying to figure out why is the way it is and how that will affect your analysis. It can be a frustrating part of data science, especially if you're newer to the field and don't have a lot of experience. For dealing with missing values, you need to use your intuition to figure out why the value is missing. One of the most important questions you can ask yourself to help figure this out is this. Is this value missing because it wasn't recorded or because it doesn't exist? If value is missing because it doesn't exist, like the height of the oldest child of someone who doesn't have any children, then it doesn't make sense to try and guess what it might be. These values you probably do. These values you probably do want to keep as n. On the other hand, if a value is missing because it wasn't recorded, then you can try to guess what it might have been based on the other values in that column and row. This is called imputation, and you'll learn how to do it next. So when you have values that are missing because they probably don't exist, you should probably drop them. And when they do exist, you should probably replace them with the mean or some other numerical value that gives you a nice representation. Not a nice, but a potentially more accurate representation of what the value would be. Which makes sense. Let's work through an example. Looking at the number of missing values in the NFL data frame, I noticed that the column times sec has a times sec has a lot of missing values in it. Time and down, so by looking at the documentation, I can see that this column has information on the number of seconds left in the game when the play was made. This means that these values are probably missing because were not recorded, rather than because they don't exist. So it would make sense for us to try and guess what they should be, rather than just having them as NAs. On the other hand, there are other fields like penalized team that also have a lot of missing fields in this case, though the field is missing because if there was no penalty, then it doesn't make sense to say which team was penalized. This column, it would make more sense, blah blah blah. It's basically saying the same thing that I said before. Drop missing values. If you're in a hurry or don't have a reason to figure out why your values are missing, one option you have is just to remove any rows or columns that contain missing values. Don't generally recommend this approach for important projects. It's usually worth it to take the time to go through your data and really look at all columns, the missing values one by one, to really get to know your data set. The issue that I see with this is, what if you have like 1,000 columns? You're not going to be able to look at all of them. So I think there must be a library or some way that people created to handle these situations. Or they just might replace every every data point with a numerical value like the mean or something like that. Or other number that makes sense. For sure, you want to drop rows with missing values. Pandas does have a handy function. Drop an A to help you do this. Let's try it out on our NFL dataset. So drop an A drops no values, I think. It looks like we remove all our data. This is because every row in our dataset had at least one missing value. You might have better luck removing all the columns that have at least one missing value instead. Remove all columns with at least one missing value. So X is 1 is for column, I think. I remember seeing this before, outside of this course. We lost quite a bit of data, but at this point we have successfully removed all the NNs from our data, deleting missing values automatically. Another option is to try and fill the filling the missing values. For this next bit, I'm getting a small subsection of the NFL data so that it will print well. We can use the pandas fill and a function to fill in missing values in a data frame for us. One option we have is to specify what we want the NaN values to be replaced with. Here I'm saying I would like to replace all the NaN values with 0. I could also be a bit more savvy and replace missing values with whatever values comes directly after it in the same column. This makes a lot of sense for datasets where the situations of some sort of logical order to them. So method bfill x is 0. Places all the anonymous values that comes directly after it in the same column. And these fill and A's filling with 0, I guess. X is 0, I think, is rows, and columns is 1. So now the exercise is run the next code cell to load the libraries. I'm gonna go to the bathroom real quick. I think this cell ran before the other one. This is the code cell below to print the first 5 rows of the SF permanence data frame. So SF permanence not have. Oops. There's a typo there. Does data sets have any missing values? Once you have an answer, run the code below to get credit for your work. So yeah, there are missing values there. How many missing data points do we have? Now is the null thing. Dot is new. Dot sum. Incorrect. No, it's the percentage. So missing equals this. Total equals the product. SF permits shape, I think. I'm not sure if it's a function or not. I'm gonna leave it without. And then here's gonna be Missing divided by total times 100. Let's see if this works. Tuple object is not callable. So S should be like this. So what am I missing? I think missing is correct. Let me look at this tutorial. Yes, there is no dot sum, missing values, np dot product. And file dot shape. Oh, maybe it's because the order that I'm doing. I should do the total first. So I think I'm doing both of them correctly, but yeah. But I don't understand why the order is that important here. Oh, because I'm getting the shape after. Oh, but I'm assigning the missing values to a different variable. Let's see if this works. Oh, still didn't work. I could also do total divided by missing there and don't multiply to by 100. But that's the way they did it here. Oh, I didn't. I need to do dot sum 2 times here because this is gonna get all the. This is gonna show the data frame in the data frame. Yes. No, this is gonna show a series with each column and how many known values each one there is. That's why it's not working. So you need to sum all the missing values from all the columns. Nice. Useful mistake there, I think. Look at the columns: street number, suffix, and zip code from the San Francisco building permits data set. Both of these contain missing values. Street number. So street number suffix is because it doesn't have, probably. And zip code is because you don't find. So zip code is probably gonna be replaced with with the previous number because they're probably located by region. and street suffix is gonna be replaced. It's gonna be dropped. Okay, I guess. Which if either are missing because they don't exist. This one. Which if either are missing because they weren't recorded. Once you have an answer, run the code cell below. What? No. It is like because it doesn't exist. Yeah. Drop missing values rows. If you removed all of the rows of SF permits with missing value, how many rows are left? So I think is S permits dot and then X is 0. Okay, so none of those. We'll take all of them on. Drop missing values columns. So now it's the same thing I did before, but rows 1, I think. X is 1 equals 1. Create a new data frame called SF that has all of the columns if empty values removed. Oh, I think there's something else I need to do. I'm gonna look at the tutorial. To specify that it's more than one missing value. How many columns were removed? The original SF permits data frame. Use this number to set the value of the dropped columns variable below. No, it's just X is equals 1. I'm not sure exactly what I need to do. There's no, that doesn't make sense as well. Mm, is dot I don't understand what I'm supposed to do here. It's asking me to use the number of the columns that have been dropped, but how can I know if I don't run the cell? I have to run the cell first to know the answer. Yeah, I'm gonna look at the solution. I don't understand what's going on with this. I have to run the cell first to get the number of columns here somehow. But then if I run, I'm gonna run both of them at the same time. Doesn't make much sense to me. Or I'm misunderstanding what they want me to should do. But I don't think it's an issue of not knowing how to do it. I have two books to read as well. I also bought another book, which is this one. And I think this guy has a YouTube channel. His name is Indian Abhishek Thakur, something like that. And I think after I'm done with reading these books, I'm gonna start the projects on Kaggle. I I'm not sure if I'm gonna finish the project that I started, which is the advanced housing regression techniques, because I want to find a project that is more interesting to me and something that I might be more curious about than house prices, because that's gonna keep me more motivated, I think, to get it all the way done. If I don't find any, then I'm gonna do the housing stuff. Yeah, this guy right here. And I think he was the first Kaggle Grandmaster or triple Grandmaster, something like that. Not even sure how these rankings work on the site yet, but hopefully it's a good book. And hopefully after I read these books, I'm gonna be able to do it all the way, the projects. Calculate number of dropped columns. Oh, so I should do the same thing. But yeah, that doesn't make sense. Oh, he's asking me to put on the. Yeah, that does make sense actually. I don't know what shape one does. Ah, it's probably the amount of columns. I think the standard for all these methods is one is column and rows is zero. So this probably gets all the columns, and this gets all the columns of the original data frame, and then this gets the columns of the frame that was dropped, and it's gonna be one minus the other. Yeah, this makes sense. Filling missing values automatically. Try replacing all the nuns in the SF permits data with the one that comes directly after it, and then replacing any remaining nuns with zero. Set the result to a new data frame. So in the SF permits data. Now is the view. No. Uh, view B0 something. Oh, there's something like that. No, view and A0. B view. Yeah, I think I don't need more practice with this. You can just research when I'm stuck doing something. This notebook, we're going to be looking at how to scale and normalize data and what the difference is between the two. Let's get started. You got our environments set up. The first thing we need to do is load in the libraries we'll be using. So SciPy's library, min-max scaling. It talks about this in the book. It's basically getting all the features you have in a data set on a similar scale to do calculations on them. I still haven't thought about what the implications of that are on different problems and how much you're sacrificing on accuracy and on the result you're getting by doing this. But I guess it works for now since people are using these strategies. Scaling versus normalization, what's the difference? One of the reasons that it's easy to get confused between scaling and normalization is because the terms are sometimes used interchangeably, and to make it even more confusing, they're very similar. In both cases, you're transforming the values of the numeric variables so the transformed data points have specific helpful properties. The difference is that in scaling, you're changing the range of your data, while in normalization, you're changing the shape of the distribution of your data. Scaling, you're changing the range. Normalization, you're changing the shape of distribution. I guess I got it. So normalization is like changing the probability curve, and scaling is changing how big the probability curve is. This means that you're scaling. This means that you're transforming your data so that it fits within a specific scale, like 0, 100, or 0. When you scale data, so scale maintains the fundamental properties of the data the relationship between data points, but just reduces the range. Normalization, you're changing the properties of the data, I guess. When you're using methods based on measures or of how far apart data points are, like support vector machines or k nearest neighbors. So with its algorithms, a change of one in any numeric future is given the same importance. For example, you might be looking at the prices of some products in both yen and US dollars. One US dollar is worth about 100 yen. But if you don't scale your prices, methods like SVM or KNN will consider a difference in price of 1 yen as important as a difference of 1 US dollar. This clearly doesn't fit with our intuitions of the world. With currency, you can convert between currencies. But what about if we're looking at something like height and weight? It's not entirely clear how many pounds should each 1 inch or how many kilograms should each go 1 meter. By scaling your variables, you can help compare different variables on weekly footing. To help solidify what scaling looks like, let's look at a made up example. So, generating 1,000 points based on exponential distribution, scaling the data between 0 and 1, then is plotting the two compare. So it's the same data, but this goes from 0 to 10, and this 0 to 1. Notice that the shape of the data doesn't change, but that instead of ranging from 0 to 8ish, it's now ranges from 0 to 1. Normalization. Scaling just changes the range of your data. Normalization is more radical transformation. Part of normalization should change our observations so that they can be described as normal distribution. This intuitively this makes me think that this can be very bad for a bunch of problems. In general, you normalize your data if you're going to be using a machine learning or statistics technique that assumes your data is normally distributed. Some examples of these include linear discriminant analysis and Gaussian naive Bayes. Pro tip: any method with Gaussian in the name probably assumes normality. The method you're using to normalize here is called the Box-Cox transformation. Let's take a quick peek at what normalizing some data looks like. Yeah, so it's changing the probability of the data. So far, I feel like this course has been easier than the first one that I did. So maybe it's better to start with this one first. For people that are new. But maybe it gets more difficult on the next tutorials. To practice scaling and normalization, we're going to use a data set of Kickstarter campaigns. Kickstarter is a website where people can ask people to invest in various projects and concept products. Next, code cell loads in the libraries and datasets we'll be using. Let's start by scaling the goals of each campaign, which is how much money they were asking for. The plot shows a histogram of the values in the USD Go Real column before and after scaling. So it's calling min max scaling here, original data column, then it specifies the column which is going to be using, and the other code plus the column. So this goes from 0 to 3, and here's 0 to 50. Or I guess 5. And then here it goes from 1.5, almost 2, from or 1. I guess the y attribute doesn't change, only the x. Yeah, because x is the range. Well, but here is 3 and here is 50, so it does change. After scaling, all values lie between 0 and 1. You can read this in horizontal axis of the second plot above and verify in the code cell below. So the values here are going from this to 0.0 something. Well, I guess it's because the data is being plotted on 10 minus 7, the y-axis, and 10 times 8 here. 10, not times, but elevated, sure. So all the values are below between 0 to 1, but they are multiplied by a 10 to some degree. We just scaled the Go Real column. What about the Go column? Begin by running the code cell below to create the data frame, original code data containing the Go column. Use the original code data to create a new data frame scale code data with values scaled between 0 and 1. You can use the min max scale function. I forgot how to type the thing. Let me think. I know there's as columns as the second argument, but this is already a column, so yeah, I don't can't remember by my memory. Also, it's the other way around. So I do have to put columns, even though it's already a column. Maybe zero works. Oh, I understand now what they want me to do. And I guess it needs to be like this. Not convert string to float. Let's see on the tutorial how it was done. Yeah. So zero is the first column, I think. So you can either put the index, I think, or the column name of the data frame. So this is probably wrong because, yeah. Let's try like this. Index data must be one dimensional. So maybe is the other way. Regional goal data. Maybe here is zero. Yeah, I'm not sure. When I look at the hints. Didn't help. Index data must be one-dimensional. Not sure what's wrong here. Maybe this cell isn't running. That's why it's failing. And it just keeps loading there. But I guess it's because this creates a series, no, a data frame only with the go column. So in order to remove the index, you have to select go. Now we practice normalization. We begin by normalizing the amount of money pledged to each campaign. Get only positive pledges using their indexes. Normalize the pledges with the method PD series stats.boxcox. Positive pledges 0. Name 0. Yeah, so this changes the data a lot, I think. Maybe. It's not perfect. It looks like a lot of pledges, but very few pledges. But it's much closer to a normal distribution. We use the pledged real column. All the same process to normalize the pledged column. Okay, so first to take the index, then you get in the positive index, then you get the index, and then you normalize. Don't know where the name of the columns are. I'm not sure if they want me to do this twice on this. Doesn't make much sense. So there's probably a column named pledged, I think. It's greater or equal than 0. No, it's just greater than 0. Now I take this one, dot lock, I think it's 0. Or it's the other way around. And dot the method. Again, mistake. Speed is serious. Positive pledges, 0. Index positive pledges. Let's see if this works. If it does, I'm just gonna look for the solution. It's taking so long to do this. Oh, maybe I should plot as well. Not sure. I don't know if there is a pledged column as well, or if I'm reading the instructions the wrong way. Correct. Nice. Oh, maybe, yeah. I'm just plotting the same thing as the other one? No, because I reassigned here, so it's correct. The positive and the normalized. Parsing dates. Got our environment set up. So this is the third of the five, fifth, five, so 3 March ago. Check the data type of our date column. We begin by taking a look at the first 5 rows of the data. We'll be working with the date columns from the landslides data frame. Let's make sure it actually looks like it contains dates. Yep, those are dates. But just because I, a human, can tell that these are dates doesn't mean that Python knows their dates. Notice that at the bottom of the output of head, you can see that it says that the data type of this column is object because it's a string, probably. Pandas is the object data type for storing various types of data types, but most often when you see a column with the dtype object, it will have strings in it. If you check the pandas data type documentation here, you notice that there's also a specific datetime 64 dtypes. Because the type of our column's object rather than datetime 64, we can tell that Python doesn't know that this column contains dates. So it's assuming there is a string. Not assuming it is a string, probably. We can also look at just the D type of a column without printing the first few rows. Oh, OBS disconnected. Yeah, I'm having trouble. My OBS is disconnecting. Looks like it's back now. So I'll probably stop right after this section here. Because my internet's probably bad. Okay, so this tells what data type it is. The thing is that I want to finish this because I drank coffee, so not I think it's gonna be the best thing to read now. It's probably gonna be better to read later on the day. May I have to check the NumPy documentation to match the later code to the D type of the object. O is the code for object. So you can see that these two methods give us the same information. Convert our date columns to datetime. Now that we know that our date column isn't being recognized as a date, it's time to convert it so that it is recognized as a date. This is called parsing dates because we're taking in a string and identifying its components parts. We can pandas we can pandas what the format of our dates are with a guide called as string directive, which you can find more information on at this link. The basic idea is that you need to point out which parts of the date are where and what punctuation is between them. There are lots of possible parts of a date, but the most common are percentage date for a day, percentage D for a day, percentage M, 1% year for two digit year, and caps lock for 4 digit year. So this is the formats for dates. Yeah, OBS is disconnecting, connecting. This is distracting me a little bit. So the lower caps gives 0, gives 2 numbers, and bigger caps gives 4 numbers. And also the dashes there. Looking back up at the head of the date column, it's disconnected again. In the landslides dataset, we can see that it's in the format month, day, 2 digit year. So we can use the same syntax as the first example to parse in our dates. I don't know what's going on with this. I think it's disconnected again. At least it's recording, seems like. So maybe it's a problem with Twitch. Not really OBS. Yeah, reconnection successful. So I think what I might do now, it looks like it's reconnected, but since I'm not sure if it's recording or not, or if it's dropping the recording, I think it's probably better to stop now and come back later. Stand 33. Or maybe I should just watch things on stream instead of doing the tutorials. I think that's what I would do. I'll stop this course right now. I'll close the stream. And then I will read about read solutions for the project, house prices, advanced progression techniques. Because I already looked at some of them, and I'm not sure if I'm gonna finish the project. So I think it's good to see the. I already did the thing that the book covers, which is data cleaning and organizing the data before you run the machine learning stuff. But the book doesn't um, didn't go into yet the machine learning part. So I think it might be good to look at the learning stuff from the other solutions to get an idea of people what people usually do. Yeah, I think that's what I'm gonna do. So I'm gonna stop the stream now and come back and look at the solutions for the advanced regression techniques since it's stopping a lot. So see you soon.